This is the hardware for WECON PLC. They are connected via a WAGO switch, Ethernet switch. If we energize the digital input in the WAGO, it will energize the digital output in WECON, as we can see. And if we energize the digital input in WECON, it will energize the digital output in WAGO. From this lid. Hello, in this video I will show you how to connect WECON PLC LX5SN with the WAGO PLC via Modbus TCP protocol. The first thing you need to know and to configure is the IP address of the WECON PLC. You can go to Ethernet settings and make the IP address as the following: 192.168.2 and 19. By this way, you have configured the IP address of the PLC. Then you want to make the socket and the channel between the WECON PLC and the WAGO PLC. You can make a new socket with this tab, and you make the socket ID, and the TCP protocol is the TCP, and the operating mode the client side. The client side means that the WECON PLC is the master of the network, and you make the target IP of this IP will be the WAGO IP address. The target port for Modbus TCP is 502. I have already made this socket, and these are the settings. You just need to know the socket ID, the protocol, the client side, and the IP address, and the target port. This target port will be on the slave of the network, which is WAGO PLC. Okay, and this is a simple project, a simple program that is used to program the WECON PLC. These are the initial settings. You can see that at the first cycle of the program, we want to reset these registers that are used to make the connection in the network. This is the socket open instruction used to make to open the socket between the WAGO and the WECON. And these are some bits that is used in the network. Here are the 4 instructions that you need to configure to read a register, read coil or a bit, and read and write the register and write the coil. The first thing is K1. K1 is the socket ID. H103 1 is the ID of the slave, and 3 is the function code. Function code 3 is used to read a single register. 3002 in hexadecimal is the slave register address. If you open the addresses in the WAGO PLC, you will see this address of the related register. K1 is the length of the registers that you want to know, that you want to read, and D500 is the target register that you want to store the value in this memory. The second one is the K1 is the socket ID, as we have said, and 1 is the ID of the slave. 1 is the function code, which is reading a single coil. 3003 in hexadecimal is the target address, the coil address or bit address. K1 is the length, and here we can store just in a register, and then we can extract the bits. As we can see here, 492 and 99.8. This will open or this will energize a digital output of WECON PLC. Then you can write a register. 6 is the function used to write a register for in the slave, and 5 function code is used to write a coil. This is the program. Here we can see that we have M0 will be always on, and K, this is a move instruction used to move 222 decimal value to this register used to in the WAGO PLC. And this one is digital input. If the digital input is energized, it will move K1 to 400 register 477. This will write the coil in the WAGO PLC. And if it is not energized, it will move 0. And this is the reading coil from the WAGO PLC. If we run the program monitor mode, we can see here that it reads a 565 and write a 222. If we go online in the WAGO PLC, you will see that this value is 222, and this is the value for reading, and this is the value for writing from WECON PLC. So let's log out and discuss the program in the WAGO PLC. Here is the WAGO PLC used as a digital output and digital input card. Here is the Modbus addresses. As we can see here, write word or register. The address is 3000 as in PLC WECON. This used for writing the register. And this one, its address is 3010 in hexadecimal. We can see it here. And the address of the reading register is MW2. Its address in Modbus protocol is 3002. 3002. It's used for reading. And this is how this address will be used in WAGO program, and this is the address for the Modbus network. These are the data types. So this is the program. Here is digital input. It will energize the coil that will be read by the WECON PLC. And this is the coil that will be written by WECON PLC and energize a digital output. And these are the registers for reading and writing. If we run the program, as we can see, this register is written by WECON PLC, which is K222. And this register will be, this digital output will be energized by the WECON PLC. I will show you. This is from WECON PLC. And this input will energize a coil of WECON PLC. I will show you now the how the connection will be in the physically.